We are to find all of the zeros of the polynomial p of x equal to 6x to the fourth minus 7x cubed minus 13x squared plus 4x plus 4. We'll begin by finding all of the possible factors of the constant term 4, and we'll give those values the designation p. So that'll be plus or minus 1, plus or minus 2, and plus or minus 4. Then we'll do the same thing for the leading coefficient, and we'll call those possible factors the q values. So we would have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, what we need to do then is construct all of the possible ratios of the p values over the q values, and those will be our possible rational roots for this polynomial. So in other words, we would take 1 and put it over each of these values. So we would have plus or minus 1, plus or minus 1/2, plus or minus 1/3, and plus or minus 1/6. And then we would take 2 and put it over each of these values. So we would have plus or minus 2, and then plus or minus 1 when we go 2 over 2, but we already have that. So then the next one would be plus or minus 2/3. And then when we go 2 over 6, we'll have a third, which we already have. Then we'll move to the 4. 4 over 1 would give us plus or minus 4. 4 over 2 would give us 2, which we already have. And then we'd have plus or minus 4/3. And then 4 over 6 would give us 2/3, which we already have. So these are all of the possible rational roots for this polynomial. Now we're going to determine which of those are the actual roots for this polynomial. And we'll do that by using synthetic division. So we'll go through here and we'll choose one of these values to use. And let's start with -1. So we're going to do a synthetic division, and we're going to do that using the number -1. So we'll put that little -1 in a half a box, and then we'll take the coefficients on the polynomial and write them out to the right of that. We'll notice that each of the descending degrees of this polynomial present, we have x to the fourth, x to the third, x squared, x to the first, and then a constant term. If any of these were missing, we would have to hold the place by putting a 0 in line. So now we'll draw our line, bring down the first term, and then multiply. -1 times 6 is -6, and then add. -7 and -6 is -13. -1 times -13 is +13. We'll add and get 0. Multiply -1 by 0, and that gives us 0. 4 plus 0 is 4. And then -1 times 4 is -4. Add, and that gives us 0. Now the remainder theorem tells us that this value here is the remainder whenever we divide this polynomial by x minus whatever number we put in the box. So in other words, if we took the polynomial 6x to the fourth minus 7x cubed minus 13x squared plus 4x plus 4 and divided it by x minus -1, or in other words, x plus 1, it would divide evenly. We know that because this value here is 0, which means that the remainder would be 0. Now the resulting polynomial would be found using these coefficients from this synthetic division. In other words, this quotient would be 6x cubed, and the 6 I get from here, minus 13x squared, get the minus 13 here, plus 0x, and then plus 4. Notice that the degree of this polynomial is 1 less than the degree that we started with because we divided by x to the first. So now we have identified one of the rational roots, and that is -1. Now we need to find the others. And we can do that using the coefficients that remain. So we'll do the same thing again. We'll choose another value. So let's choose 2. And so we'll bring down 6. 2 times 6 is 12. If we add, we get -1. Multiply, -2. Add, we get -2. Multiply, we get -4. And we get a remainder of 0 again. So we have found then that x minus 2 is also a factor for this polynomial. So we have factored this thing to a degree, and it looks like this: x plus 1 times x minus 2 times 6x squared minus x minus 2. Again, these coefficients come from this line at the bottom of this synthetic division. So if we were to multiply these three factors together, we would result in our original polynomial. So now we've found two of the roots, x equals -1 and x equals +2. What we have left is a quadratic, and we can find those roots either by factoring, if it will factor nicely, or by completing the square, or by using the quadratic formula. Let's just use the quadratic formula to see how that's going to work. Now remember that the quadratic formula tells us that we can find the roots of a quadratic function using the formula minus b plus or minus the square root of b squared minus 4ac, and all of that is divided by 2a. So we'll need to identify a, b, and c. So a will be 6, b will be -1, and c will be -2. So x then would be the opposite of b. B is -1, so that's going to be +1, plus or minus the square root of b squared. B is -1, and if we square -1, we get +1, minus 4 times a is 6, times c is -2, and the whole thing then is divided by 2a, so 2 times 6. And when we simplify this, we're going to have 1 plus or minus 7 over 12. So this is two results. This is 1 plus 7 over 12 and 1 minus 7 over 12. And 1 plus 7 over 12 will give us 2/3. And 1 minus 7 over 12 will give us -1/2. So our zeros for this polynomial would be -1, 2, 2/3, and -1/2.